So I'm just going to work through an example with you here, page 306, 19.1. So a sample of water was analysed in order to determine the total amount of hardness in the water. 50 centimetres cubed of the water were placed in a conical flask and some buffer solution and a rheochrome black tea indicator were added. The solution was titrated against 0.01 molar EDTA solution. The average titration figure was 15.2. You're asked to calculate the total amount of hardness in the water. First thing just to note here is that in a question exam, it'd be a lot more lead than this. So firstly, we have to find our moles per litre. Then we have to find our grams per litre. And then finally, this is always going to be expressed in ppm. Another thing then that will be given to you is the balanced equation. So underneath that, I'm going to write what I know. Remember, the water sample here is my Ca2 plus because that is the amount of hard water I'm looking to find. Then I have 0.01 molar of EDTA and I have 15.2 centimetres cubed of that. Okay, so that means I have 0.01 molarity means moles per litre, which is 1,000 centimetres cubed. I don't have 1,000 centimetres cubed in this question. I only have 15.2 centimetres cubed. So I multiply 0.01 by 15.2 and I divide that by 1,000, which gives me an answer there of 1.52 by 10 to the minus 4 moles. That's my number of moles of EDTA. I'm asked for my number of moles of hard water, so I have to get this into an equation. My ratio here is 1:1, so if I have 1.52 by 10 to the minus 4 of EDTA, I'm also going to have 1.52 by 10 to the minus 4 moles of calcium ions. Now, that 1.52 by 10 to the minus 4 moles I'm given in the question is only in 50 centimetres cubed. So if I'm asked for it in moles per litre, I have to convert it here into 1,000 centimetres cubed. So I multiply by what I know and I divide by the bit left over. So this gives me an answer here of 3.04 by 10 to the minus 3 moles. After that, then we'd be asked for it in grams per litre. So I have to use my number of moles equals mass in grams divided by my relative molecular mass. And it is my relative molecular mass, my calcium carbonate is always what I use to measure my total hardness. So calcium is 40 plus 12 plus 16 by 3. And that gives me a total of 100. So I multiply 3.04 by 10 to the minus 3 multiplied by my relative molecular mass of 100. And that gives me a mass in grams of 0.34 grams per litre. Remember, ppm is milligrams per litre. So I have to multiply that by 1,000, which gives me 304 ppm or milligrams per litre. And that is the answer.